All right, today we are going to talk about exponential rules. The original plan for today was that we were going to go through and do some applications of right triangles and things like that, but quite honestly, the amount of time that we would need to spend on that is probably a little longer than we want to actually spend, because I want to go through and do some trust work and do that, which is probably about like a 3 or 4 day session. And I want to make sure that we move on to Chapter 8 and get through everything before the end of the course. So we're going to take a couple days and we're going to talk about exponential notation, exponential simplification, which is what I plan on doing after we talk about applications of right triangles anyway. So it's just kind of moving that forward. Today we're going to go through the basic rules of exponents. On Monday we're going to do some application of exponents. And then on Tuesday, I'm going to give you a short quiz over that. That means that on Wednesday next week, we will start with Chapter 8, which is quadrilateral. Now, quite honestly, the reason that we are going through and discussing all of this is that when we look at the things that we see on the end of course exam, there are a lot of these exponential notation, exponential simplification problems within a geometric context. So, for instance, this was a problem that we saw on, this is exponential. So just call this alpha, chapter alpha, how's that? So, alpha is this. Alright, so this is a problem, or similar to a problem that we saw in the end of course exam. Question says, find the area of this object where this is the base and this is the height. Right? Now, we know that the formula for area is 1/2 base times height. So we had to go in and plug in. And then we needed to simplify from there. Okay, so this problem is not horribly difficult, but it is if you don't remember all your rules of exponents. Okay, so that's why we're going to spend some time today going right through to make sure we know what we're doing. Now, this is a review of algebra. You've had this stuff before, so as we go through it, if you look at it and you're like, I really remember this, I know what we're talking about, this all looks familiar to me, that's good. That's what we want. If it looks familiar but you don't remember all the pieces, this is the review component of it. This should be not new to, or excuse me, should be new to none of you. Okay? It should be not new material for you. Yeah, 48. Alright, now, when we look at exponential rules, there are really 6 rules that we care about. Now, I'll tell you that if we go through and look at the Algebra 2 book, if we look at the algebra book, college algebra book, pre-calculus, they start adding in all these other crazy rules. But at the end of the day, we really only need 6 of them. Here's the first 3. What's a to the 0 power? 1. A to the 0 power is always 1. If we think of exponential notation as repeated multiplication, right? We know multiplication is repeated addition, exponents is repeated multiplication. This, we know, is just a, right? Because there's one a. If it's a squared, we'd be multiplying 2 a's, right? A cubed, 3 a's. A to the 0 means that we're multiplying no a's. Okay? There's none of these things in our expression. So all that's left is 1. Okay? You can think about it this way. Right? A cubed, a squared, a to the first, a to the 0. Now, when we move from a cubed to a squared, what are we doing? What are we doing? Huh? We're not subtracting, per se. We're removing an a, but what are we really doing? We're not subtracting, we are dividing, right? To go from a cubed to a squared, we're dividing by a, right? To go from a squared to a to the first, we're dividing by a. A to the first to a to the 0, we're dividing by a. If we have a to the 0, and we're going to go to a to the negative first, we're going to divide by a. And that is the last of our three basic things. You can assume that a to the negative second is 1 over a squared, right? Because we divided by a again. And so on and so forth. So when we look at those 6 rules, the first 3 are kind of the basics, right? In fact, a lot of times I will denote those as just our basic exponent rules, right? Sometimes books will actually just call this, they won't even call them rules, they'll just say these are basics of exponent notation. Alright, so we have those 3. Let's talk about the other 3 we need. What does that become? Not a to the n times n, but m plus n. Whenever we have the same base, we just add the exponents. Right? So a to the m times a to the n is a to the m plus n. You've done this before, right? Yes. When the classic example would be x squared times x squared, right? You know that's x to the 4th, right? Or actually, probably we could make this a better looking example by making this 3, right? So this becomes x to the 5th. Our next a to the m that is raised to the power. This one is I like to think of us as distributing that n in. We're distributing that n in. And then our last. This one is a to the what do we do with the m and the n? Subtract. Very good. Yeah. The thing that we need to think about, or that we can think about when we're looking at these problems, is that in many ways we understand this one, but we could really notate it in a different way. Right? Couldn't I take this problem? I'm going to switch to using x's here. And let's say I had x to the 2nd over x to the 5th. I could, if I wanted to, think of this as x times x over x times x times x times x times x. Well, this becomes a simple cross out, right? I've got x over x over x. So obviously, I've got to have 1 over x cubed. As well, I could think of this as, well, this is x squared times 1 over x to the 5th, which we could probably skip through that step and have x squared times x to the negative 5th. Right? Now, this looks like that. Looks to me like this one, right? So 2 plus negative 5 is negative 3. So x to the 3rd, which is 1 over x. So really, when we look through this, and we look at our rules, we probably can start to kind of make sense of it on our own. This one is helpful because it's fast, right? It's fast for us to use that division rule. At the end of the day, though, there's lots of ways to get around it. We really only need these two. Now, kind of an interesting component of this. If I had my way, and I could go in and dictate what mathematicians did the world over, this would be your final answer. That's what I would prefer. Because negative exponents make sense. It's something that's actually pretty easy once you get in the hang of it. Honestly, if you're going to do calculus, you really have to get used to using negative exponents. If you don't have negative exponents, calculus changes quite a bit. Unfortunately, though, this is the standard. And the standard is to not have negative exponents. Now, if we look at the history of mathematics, there's a very simple reason for that. Well, you all, at age 14, 15, 16, have more math education than most of human history. Okay? If we go back and we look at what people knew and were taught ages ago, and even in the very basics of things, this simple concept of negative exponents was not always evident or not always used. To simplify it down, we move to that 1 over x cubed. The other thing we have to think about whenever we talk about math history is that people have different ways of writing. Some people have bad handwriting. I have no idea what that's like. All right? Obi and I are together on that one. If we look at x to the negative third, I'm sure that some of this had to come from the fact that someone said, you know what, this negative exponent thing, I keep losing it, and my writing is horrible. If you look at the old text, the old math text, you'll see that like negatives have like all these little serifs on them, like the little tails and whatnot. And I'm sure that there had to be some of that in that notation switch as well. So, anyway, the big thing that we know is that we have these 3 rules. And if these were the basic exponent rules, these 3 are the basic exponent arithmetic rules. So, don't necessarily have to have those notated in your notes. Just know that if I say it's one of your basic exponent arithmetic rules, I'm talking about these 3. Got it. All right. We good? Good. Okay, now, our end goal of this is to be able to take expressions and simplify them. Okay? Our end goal of this is all to be able to take some basic algebraic statement involving exponents and simplify it. So, we'll do an example of this. I have a worksheet that I will give you and we'll go from there. So, let's say I gave you this problem. Negative 4 x to the 6 over c to the negative cubed squared times 7s squared over 14 e fourth negative. Now, when we look at this problem, it actually seems fairly straightforward. In many ways it is. The one caution I'll tell you, and if you remember from doing this in algebra, you remember your algebra teacher probably giving you the same caution that you understanding. Go slow with these. Don't try and go from this statement to an answer. It's actually going to behoove you to take this step by step, because you have to be very careful with your movement of the exponents into the parentheses, and then your eventual simplification of them. You don't want to lose something in the process. So, what's the one big thing to remember when I have an exponent outside the parentheses? What does it get done to all of them? Alright, all of them get multiplied exponent. I'm just distributing it in. So, negative 4 squared is what?
8.
Okay, negative 4 squared is positive 16. Very good. So 16. Right, then I have 6 and 2 get multiplied, so s to the 12 over t to the negative third squared is t to the negative 6, and then r to the 10. Now, what do I know about this negative out here? What does that do to the stuff inside? Doesn't make it negative, it flips it, right? It gives us our inverse, okay? It flips it over. If you are comfortable with thinking through it, flipped over, do that. Myself, I'm a big fan of going ahead and writing it out so I know what I'm doing. Okay. I just like to do that because then I don't have to try and keep things in my head. Right, so do that, 16s to 12 over t to the negative 6, r to the 10, times 14 cubed. 14 cubed, anyone?
14 cubed. Calculators? I know. Squared is 196.
2744. T to the 12. Right, 7 cubed. 343. S to the 6. All right, now, all my parentheses are gone. I can do a handy little step here, and that handy little step is to not cross multiply, but multiply straight across. I just connect those on the same line. I know I'm just going to put those together. So, I've got 16 times 2,744, big number, 43904. Then I've got s to the 12 times t to the 12 over 343. And then I'm going to line up my exponents in the same order. Again, not something you have to do, but in the interest of keeping things organized, it's a very nice little step. Because then I can go through and look those, and then those. So, I'll simplify down. When I divide that, I get 128. S to the 12th over S to the 6th is what? X to the 6. We're at here? Yes. Sorry, bad handwriting. Alright? T to the 12th over t to the negative 6 becomes t to the 18th. Very good. Because I've got 12 minus negative 6. Okay? Or when it comes to the top, I'm going to put it together. So t to the 18th. And then I have 1 over r to the 10th. So I'll leave it as r. Now, that's it. You could argue, well, that's a lot of steps that you have to go through and whatnot, but at the end of the day, keeping things organized with this is much, much better than not. You'll eventually have to do some exponential simplification, which is within a logarithmic setting, and that's just adding another layer if we were dealing with radicals or fractional or rational exponents, excuse me. That is one next step that's just an additional issue. And if we can keep things organized now, life's going to be better. Questions? All right, I have a worksheet for you. The plan is there's 39 questions on here. On Monday, we're going to go through and we're going to randomly choose 20 of them. Great. Okay, so got to do all of them, but we're going to randomly choose 20 of them to grade. When I say randomly, we're going to use a random number generator. It's not just me going through and saying, oh, let's do this one, or this. Okay. All right. With that, I'll let you go. Bye.